In your observations, write up a hypothesis. Write down a hypothesis. What do you hypothesize is going to happen? Well, now we're getting observations here. But the hypothesis would be that, if this is heavier than that, then this is going to move over there. But since it's the same volume, this is going to have to be displaced, and it's going to get pushed over here. So what's really happening is this is not pushing that water out of the way. This water is actually pushing that water out of the way, and this water is passively coming over to replace it. So it's being sucked over and lifted up. Okay?
What might this represent?
Estuary.
How so?
Because the salt water is more dense than fresh water. And so the salt water sinks, and the fresh water goes over it, and the rest goes up.
Okay, anybody else got any ideas?
Or like a warmer tributary flowing into a colder, larger stream.
Yeah, like a cold stream flowing into a warm lake, maybe?
Yeah, like that.
Cold groundwater coming into a warm lake. That would be
Like a hot spring flowing into a cold lake.
Yeah, hot springs and fluid. So, yeah, the estuaries, that would be a salt type thing, but that happens, like, for example, that would be, let's see, which is heavier here, this is heavier. So this would be like ocean water, and this would be like the Columbia River. And so the fresh water would flow over and the salt water, and that's called a salt wedge. And that does, in fact, this is correctly pointed out here, very important in a lot of estuaries, where you have a layer, for example, in the Mississippi River, you can go all the way up to, like, Baton Rouge, way up in the Gulf of Mexico, and it's fresh water at the top, and you drop a sampler down to the bottom of the Mississippi, it's salt water down there. So rivers can be salty on the bottom and fresh on the top, they connect to the ocean because of this phenomenon here. Matt probably wants, I think Matt's thinking you got another theory out there. What would that be? Well, what's another system, common system? In fact, we've kind of talked about it a little bit in class. Anybody taking limnology? Lakes?
I thought there were some people in here.
Stratification. Just regular stratification.
Yeah, what do you mean by regular stratification?
Or I guess you could chemically stratify it like too.
Well, this is temperature, though, so what's this
Thermal stratification.
Thermal stratification, which is what?
Denser water sinking to the bottom, colder on the bottom, warmer on top.
Sure. So if there was sunlight, we talked about sun. Remember, light penetrates to a certain depth. So if we were warming up water with heat lamps up here, we would see the same thing. Put ice water in here, put heat lamps on top, you'd see warm water, cold water, like this.
What will stratification prevent in the lake? Mixing. Why is mixing?
Notice I'm inducing some mechanical mixing. Now this would be analogous in a lake. You don't have a giant telephone pole sticking down and stirring up the lake. So what stirs up the lake naturally? Wind. So I can't really do that justice over something called fetch. Fetch being the term in lakes for the distance the wind blows over. But I can do the equivalent of it. But notice that interface is, while I can kind of kick it up a little bit, notice it's fairly resistant to mixing. It kind of bounces, but it doesn't want to go. In fact, if I want to mess with it, it's actually a little tricky. If I mess with it, it'll settle back down. So this is also, I mean, this is like an inversion. This is the same thing that occurs if this is cold air with warm air on top. If this were air, there's my cold air trapped down there, and I can't mix that pollution up. So that blue represents the polluted layer of air, and we try to get that stirred up, and it just doesn't want to go on its own. So it's resisting mixing. All right. Now, and the other question, we could have had this, I could have posed this as a hypothesis, but it's obvious now. I should have said this earlier. Where would you expect the two boundaries? Would you expect them to be at different levels or same level? No, the boundary here and here.
Different. Same.
Yeah, because think about it, no matter how much you have, we have the same volume, the same level here. It can't be at different levels, or else it's not going to be in equilibrium. So actually, it is actually good. Right, this cold water weighs the same now as this cold water here. This warm water weighs the same as this. So otherwise, you still wouldn't have an equal distribution of light over heavy. And like I said, that boundary, you can see you can get a little blending, and that's what happens. This represents a lake in the summertime where it's just very resistant to mixing. Okay, now it's going to be October and the windstorms kick in, and now it takes a fair amount of work. Soggy pen. Actually, totally can see that the bottom water just doesn't really want to go over. Okay. Now, there's actually one more thing we can observe here. I didn't even think about this until I did this Tuesday, and thought I was done with the experiment, and I'm yakking away, and somebody said, oh, well, look, something else is happening. So let's see if you can see what's happening here. It's not real obvious, you have to come a little closely. Well, actually, let's hypothesize. What should something happen now?
The other side is going to start, the equilibrium on the other side of layers are going to start rising because they want the differential temperatures want to be the same between the two chambers.
Yeah, by stirring, one way to think about it is by stirring cold water up, did I make the top of this a little heavier? So I brought some of that dense water up higher. And so another simple way to analyze it is this water here the same temperature as that water there? No, this water is warmer and this water is colder. So this water is going to displace some of this water here. And is this water warmer or colder than that water? This is colder, so it's going to kind of travel over and tend to sort of sink down. It's a little hard to see it today. Although actually, if you look through here, look closely, you can see how, that might be lack of mixing. You can see that there's a nice bright blue there and it's sort of this purpley gray here. I think the colors are not as distinct. When I did on Tuesday, this was more gray, purpley, and it was more obvious. But anyway, at least we can hypothesize. We don't necessarily observe it all that well. Oh yeah, there it is. See the red layer? You got to get it right. Yep, sure enough. Nice red layer right there, so if you can't see it. Now you can. Okay. Anyway, simple little experiment. I like things that involve colors, and dyed water is always fun.